Well, good morning. Welcome back to the Tin Barn. I'm Pragmatic Lee, of course. Today's project is going to be just going to call it a copycat project. A couple weeks ago I was on the Hobby Machinist forum in the Precision Matthews subforum, and there was a thread talking about locking the y-axis on benchtop mills. In particular, they were talking about the Precision Matthews, but I'm reasonably certain about all the benchtop mills are pretty much the same, where you've got to reach under the table and tighten down some type of a grub and screw under there. In that thread, the guy was talking about asking for solutions and whatever, and well, let me show you first off show you what was in mind to begin with. And I want to say, I'm not being critical of Precision Matthews. A lot of times guys will see my videos and I catch a lot of flack because I talk about things I'm changing on the mill or changing on the lathe. I'm not being critical of Precision Matthews. There's a lot of fanboys out there, I understand, but there's just a few little things that can be improved on any of these hobby size, home shop type equipment. This is what comes on the PM-727 mill to tighten the y-axis. This actually grubs up against the gilb in there. You've got to reach under the table. You've got a greasy lead screw up here. You've got to reach under that table, get hold of this, and tighten it. Turn it up to tighten it. In this one in particular, on mine, this one was just enough too long that it would actually wedge on the ledge. There's an L-shaped ledge, the base, and then the track for the y-axis to ride on. So this wasn't a good solution. It worked a little better after I raised my mill up a little bit higher than originally, but I came up with this quick little solution. This is nothing more than an 80 millimeter by 90 millimeter long bolt. I made a little handle out of some scrap I had in my bin over there. I didn't even bother on the rotary table. I just set it in the mill, grubbed a spot or milled out a spot, turned it what looked like 90 degrees, milled another one, 45 degrees, and so forth, and then put it in there and drilled and put a spring pin in there. And I was happy with this. I was getting along fine with it. As a matter of fact, I replied to that thread and posted a couple of pictures of this solution. And again, I was happy with it. But then along comes somebody with a even better better idea. Guy named Joe on the forum, and I got to tracking him down. He posted a little video of his. Some of you may know him well. He's another YouTube creator. His channel is called Cup of Joe, C-U-P-P-A space Joe. And he come up with an even better solution. And when I saw that, I said, okay, I've got to do that. So that's what we're going to try copying today. Let me move the camera around and I'm going to show you. I actually drew some plans for this project to try to get it in my mind before we start on it. So let me bring the camera around and show you what I've got for plans on this. Okay, here is my interpretation of what Joe did on his. What we're going to do is take some, this is half inch thick by 1.5 inch aluminum block. I've cut it 2.5 inches long. We're going to drill an 8 millimeter in the top of it. This is going to be a 1/4 down in the bottom. Then we're going to, of course, mill out our angles on there. There'll be a couple of bolts through here, going in just like this did. This is spaced, and there'll be a piece of linkage down here at the bottom tying the two together. And I'll fabricate some type of handle on the lead one so I can pull this up, lock it, drop it back down, and unlock it. These will be 8mm holes here. There'll be an a 1032 grub screw, set screw. We'll tap the side of that. I have looked under there. Excuse me, I'll be able to get access if I actually install that without this way and the back one out in that direction. I'll be able to get in there and tighten it. So what we'll do is put a bolt in, tighten it to the desired torque, set the grub screw tight on that, put our linkage in the bottom across here, or turn the other bolt to the same torque and time the two together. It won't be, shouldn't be very difficult to do. It may take a little trial and error until we get them both locking good. But what we're going to do first is lay out on these aluminum blocks. We're going to lay out both of them for our pieces. I've done some rethinking on this. On this linkage that'll go between them, I'm a little bit concerned. There'll be a slot cut up in here. But my slit and saw will only go about a little less than an inch deep. And I'm afraid this is not going to be, there's not going to be enough travel in there that when this swings around here, I'm afraid it'll hit on the bottom of the slit. So all I'm going to do, I'm going to modify this just a little bit to make it an L on each end. Something to that effect. Be the same thing over here. And the hole will be up here instead of down there. And then that way there's plenty of linkage. I'll do that out of this, I believe that's an 1.5 inch piece also. Now the distance between these, as Joe mentioned in his video, he's not really sure that there's any standard for that. He did not give any measurements on his. Mine turned out to be 2 3/4 inches between that, but I know that's just a coincidence because everything else on there is metric. But the mill he was working on, I believe, is Grizzly. It's I believe he said it was one of the older round column mills. But in any case, just measure the distance between your two grub screws that's in there now, or it'd probably be something like this. Measure that distance. Alright, I'm going to start and lay out these pieces here. It'll just be a little drawing. When I get that done, I'll bring the camera back and show you what I've done. I'm going to attempt to see if I can actually video some of this layout on there. Some of you may be interested in that. As I say, this is a 1.5 inch wide. I've got my calipers marked out at 3/4 inch. So I'm going to put a scribe mark on both pieces for the center line. The edge of this one has got some roughness on it, and it was the last piece of this 1.5 inch that I had. I'll go ahead and put a center line on this as well. Not sure that we'll need a center line on that, but we'll see. Still thinking about how I'm going to do that. And then the 8mm that's in one end will be 3/4 inch from that end. Alright, the 1/4 inch hole that's going to be the 1/4 inch hole that'll be down here on each one needs to be a 1/2 inch from each end. So get the caliper set up for that. These are probably actually going to be drilled together on the mill, but I like to go ahead and lay them out anyhow to see what they look like. Okay, let me check my notes right quick and be sure that is what I wanted, a 1/2 inch. Yes, okay. Now I've got the set of dividers here set up on 3/4 of an inch. Let me double check that. Yes, it should be the same as the radius over there. So I'm going to see if I can keep this in camera and get a scribe line. Alright, not sure if you can see that, but that's scribed on there, and then we want to do the same thing on the other one. To cut this radius on the end, I'm not going to go to the trouble of setting up the rotary table. I'm going to attempt to use a little method that Dale Derry showed on his metal tips and tricks. I'm going to attempt to use that. Maybe I won't mill the end of my fingers off. So now we want, on the other end, we want a small radius over there. I set that up a 1/2 inch from the end. So we'll set that radius the same. Tell you what, that scribe would set there a whole lot easier, or those dividers, with a hole, with a punch hole started. Okay, now let's try, see if the dividers will stay in there a little better. Alright, looking at, I need to set this hole a 1/4 inch or maybe 3/8 of an inch from the end. Let me look at that again. Okay, I went back and put a this mark. I had it right on the drawing here. I had it proper on the drawing. I just had it in my notes over here on this side. I had it at a 1/2 inch instead of a 3/8 inch. So we'll put there, scribe our radius on both. And I'm going to try to keep this in the camera frame and get my scribe. But all we're going to do now is find the tangent between these two. And scribe a line there as well. Okay, so maybe you can see it in the camera in there. This little bit of radius that will be on this end down here is so small, I'll just do that on the belt sander as I clean it up. Alright, let's do the same thing on this one. Now to set these up on the mill, in the mill vise, I need to know approximately what that angle right there is, or a pretty good idea of what that angle. And that looks like And that looks like 13 degrees on that one. Let me see how this one comes out. Should be, of course, all be the same. And that's right dead on the money. So 13 degrees is what we're going to look for. We'll set these two up on the mill, and I'll get the camera over there. We'll drill out our holes first. No, I'm sorry. I think the first thing we're going to do before we do anything else is cut that slit in there. Cut it as deep as it'll go. Then drill our holes and drill and tap for our set screws in the side, and start milling the angled sides, and then finally we'll mill the radius on there. So I'll get set up on the mill and be right back. Alright, I have one of our pieces mounted in the vise now, with the small end toward the slitting saw. I'm going to ease down on it, zero out my Z-axis, come down, and ease up to touch the bottom, and that's 634. 0.634 divided by 2, 317. That's where we need to come up on our Z-axis. Okay. Be sure it's in there tight. Now we're going to ease into that, see how that cuts. It's aluminum, but I still don't want to take a whole lot of chances with it in one pass. Put a little WD-40 on it, give them chips a chance to get out of there. Okay, that looks good and centered. I believe I will slow it down though. Alright, let's go on in. We'll take a pretty good bite this time. And I'm going to ease that in right gradually on the axis, I tell you what, let me back it out. Just don't want to, again, my spindle depth, or the diameter of my saw blade is going to determine how deep I can go in there. And I believe that's going to about be the max there. Alright, we'll rinse and repeat and do that on our other one. The Z-axis depth should be good if I get it down on the parallels like I got this one. We shouldn't have to reset that. See, here's what I was talking about. I was a bit concerned of when this rolls up that was going to be deep enough. So we're going to modify our piece of linkage in there just a little bit. Get it up there where we can take a look at it. Lock our X down. Locking our X down. I believe I can go just a little deeper on that one. Get it like the other one was. Alright, that's our two slits cut. Now I'll get set up with the drill chuck in the mill and we'll drill our two holes. Okay, I have the drill chuck set up in the lathe now. I've got both pieces stacked in there. I've got them lined up, and I have a piece of copper wire. Again, one of these pieces had a rough edge, so I don't want to be sure nothing slips in there. So I've just put a piece of copper wire for it to bite on. And therefore I'm going to, instead of centering up between the lathe jaws, I'm sorry, between the vise jaws, I'm going to actually center on the piece of work itself, since there is a number 12 piece of copper in there. We'll get this down. Zero out the Y, and then we'll see if that repeats. Dead on it, so I'll come back to the other side. And be sure we're not on our piece of wire. .704. Try that again. On the money, so half that, 1.704 divided by 2, 852. Alright, we'll lock our Y down. Now let's go off to the end. Even though we marked that, we're still going to take our measurements on that. I marked it just primarily to draw that radius and get the tangent on there. But we're going to be a little more precise in the actual drilling. Zero out the X. And that repeated. Probe is 100,000, so we'll come over 50. That should be centered over the edge. Now we'll take our 750 thousandths. And mark that Z position as well. Now this will be our 8mm on this end. My drill chuck. Let's see, let's get it's a fairly stiff bit, but I still think I want to go ahead and get a start with that. Want to be sure everything stays lined up. Alright, our next hole is going to be the 1/4 inch one. And for this project, probably starting out today, I don't know whether I'll get around to it, but I'm actually going to make some 1/4 inch shoulder bolts to go on this side. To get it set up or see how far we get in this part of the video, I'll probably just use a inch long threaded bolt. But let's see what the distance there should be. Alright, our total length of our piece was 2.5 inches. We come in 3/4 from this end, and if we come in 3/8 from that end, that should leave us 1.375, 1 3/8 inches in between the two holes. So let's do that on our x-axis. That should be fairly close. Yep. Alright, so let's get us a hole there. And again, this will be the 1/4 inch down here. Why mix metric and SAE? Because that's what I got. Alright, there's our two holes. Now we need to turn these up on the edge and drill and tap full of set screw. These need deburring just a little bit. I'll get that set up and then be back.